Welcome to this lesson on alkanes, one of the most fundamental classes of organic compounds. Alkanes are saturated hydrocarbons, meaning they contain only single bonds between carbon atoms and are saturated with hydrogen atoms. Understanding alkanes is essential as they form the foundation for studying more complex organic molecules. Throughout this lesson, we'll explore their structure, formula, properties, and what makes them unique in the world of organic chemistry. Alkanes are hydrocarbons that contain only single carbon-carbon bonds. Every bond in an alkane is a sigma bond, which is the strongest type of covalent bond. All carbon-carbon bonds are single bonds, with no double or triple bonds present. Because of this, alkanes are saturated with hydrogen atoms, meaning each carbon atom is bonded to the maximum number of hydrogen atoms possible. The geometry around each carbon is tetrahedral, creating a three-dimensional structure. Importantly, alkanes are the least reactive type of hydrocarbons due to the strength and stability of their carbon-carbon and carbon-hydrogen bonds. All alkanes follow a specific general formula, Cₙ₂ N+2, where N represents the number of carbon atoms in the molecule. This formula allows us to calculate the exact number of hydrogen atoms for any alkane if we know how many carbons it contains. For example, if N equals 1, we have 1 carbon and 4 hydrogens, giving us CH4, which is methane. If N equals 3, we have 3 carbons and 8 hydrogens, giving us C₃H₄, which is propane. And if N equals 5, we have 5 carbons and 12 hydrogens, giving us C₅H₂, which is pentane. This predictable pattern makes it easy to identify and name alkanes. The term saturated refers to the fact that every carbon atom in an alkane is bonded to the maximum number of hydrogen atoms possible. Because alkanes have only single bonds, no additional hydrogen atoms can be added to the molecule. In contrast, unsaturated hydrocarbons contain double or triple bonds between carbon atoms. These multiple bonds can be broken, allowing more hydrogen atoms to be added through a process called hydrogenation. Saturated hydrocarbons like alkanes are stable and fully saturated with hydrogen, while unsaturated hydrocarbons can undergo reactions to add more hydrogen atoms and become saturated. Let's look at the first 4 alkanes in the homologous series. Methane has 1 carbon atom, and its molecular formula is CH4. Ethane has 2 carbon atoms with the formula C₂H₃. Propane contains 3 carbon atoms with the formula C₃H₄, and butane has 4 carbon atoms with the formula C₄H₁. Notice how each successive alkane adds 1 carbon atom and 2 hydrogen atoms, following the general formula CₙNH₂N+2. These first 4 alkanes are gases at room temperature and are commonly used as fuels. Alkanes have several important structural properties. All bonds in alkanes are sigma bonds, formed through sp3 hybridization of the carbon atoms. Each carbon atom has a tetrahedral geometry with bond angles of 109.5 degrees. Because all the bonds are single bonds, there is free rotation around each carbon-carbon bond, which means the molecule can adopt different conformations. This free rotation also means alkanes do not have geometric isomers. Additionally, the carbon-hydrogen bonds are nearly nonpolar, because carbon and hydrogen have similar electronegativities. This makes alkane molecules hydrophobic, meaning they repel water and do not dissolve well in aqueous solutions. The physical properties of alkanes show clear trends. As the chain length increases and more carbon atoms are added, both the boiling point and melting point increase. This happens because larger molecules have greater surface area, leading to stronger London dispersion forces between molecules. Alkanes are insoluble in water because they are nonpolar molecules, and water is a polar solvent. However, alkanes are soluble in nonpolar solvents like hexane or benzene. Alkanes also have low reactivity due to the strength of their carbon-carbon and carbon-hydrogen bonds, which makes them relatively stable and unreactive under normal conditions. Let's summarize the key points about alkanes. First, alkanes contain only single carbon-carbon bonds with no double or triple bonds present. Second, They follow the general formula Cₙ₂ₙ, which defines them as saturated hydrocarbons. Third, alkanes have tetrahedral geometry around each carbon atom with bond angles of 109.5 degrees. Fourth, they are nonpolar, hydrophobic molecules that are relatively unreactive compared to other organic compounds. And fifth, their physical properties such as boiling point and melting point increase as the molecular size increases. Understanding these fundamental characteristics of alkanes provides a solid foundation for studying more complex organic chemistry topics.
If you like this video, hit that like button and don't forget to subscribe. Visit CYDE-LUCKY.com for more such useful content.